Okay, so here we are. This is Team Straight and Narrow. We're just doing our midterm presentation. Our team is Fred, myself, Taylor, and Edgar. So we're just going to talk about the 7 steps of the function development process. These 7 steps consist of defining the problem, creating a test matrix, outlining solution, test algorithm, translate to code, and then run that test and deploy the code. So we're going to go through it. The first one that's going to kick us off is Fred himself.
Hey, this is Fred. Step 1 is defining the problem. This is where we're trying to look at what this function is supposed to be doing during its life. And this is for our score screen. So we're going to be taking in, the number of years, the population, our offerings, our land, and our wheat. And we're going to be compiling those together to generate a score for our reports and end game. So that's the problem that's hopefully going to be solved with this function.
Perfect. And so with that problem, we've created a test matrix. Just putting in all the inputs that are valid inputs and invalid inputs, and finding the boundary inputs also, with the year, population, acre, wheat and acres, and then finding the output for those, and then addressing the errors that happen inside of the test cases that we create. So yeah, we move that towards the pseudocode, which Edgar's going to explain.
All right, and right here we outline the solution. This is where the things needs to be catched. This could help us. This part of the code help us to ensure the integrity of the results, and of course it returns the scores after it gets completed. So right here you can see the all the if and else statements, the formula that we use, and return a score at the end.
Perfect.
All right, then we have to test our algorithm. We have to step through the pseudocode that we had made earlier and make sure that by the end we're getting the expected result. And this means not only are we getting our error coding out, our minus ones when we need those minus ones, but we catch anything that might be a boundary case. And as you can see, we have multiple negatives that would potentially give a positive, but hopefully the pseudocode that we have written down will catch those. And that's where this step comes in.
Yep. So the step 5 is just translating that pseudocode and the test algorithms that we've set up into actual code, and putting it into the NetBeans here, but any program that allows you to run that test process. So yeah, it's pretty simple. We really took what you really want to do is just take that exact pseudocode that you had before, and actually put it inside of the code with obviously more syntax, so it all works. But yeah, and then you move on to the next part, which is testing it.
All right, and in this part it's where we start the and run the test and deploy them. And right here it's where we do the small test. As you can see right here, we use the year that it's equal to 1 and so on, and because this is where the integrity of the results really will happen. So this is the code behind the matrix that we saw earlier.
All right, this is a little code segments talking about the Java selection statement here for me. And in here we see my if statements on the side, and specifically shows if statements for checking for failure states, to check large swaths of possible inputs. So anything below 0, will give me errors here. And then I need to make sure that if my wheat is 0, if it's already 0, I need to return 0, because I can't take anything out of that. Anything below 0 could damage the integrity of my internal model. And I do the same thing at the bottom when I check to see before I return it out. You can also see I use a if statement here for the tithing percent to generate the vermin, because I didn't want to generate a upside down switch statement. Though possible, it's a little bit harder to read and doesn't really save. Over here is my switch statement, which is specifically chosen to catch only very specific inputs, right? I'm checking for V, M, L, S, R, Q, and everything else doesn't work. And that's the real power of switch statements, is to be able to check all these things, low system input, and only catch the very specific things that you're looking for.
Perfect. So I did a lot the same of, put in my code that I did for my processes. Kind of like what like Fred was talking about. Now my if statements check for making sure things are valid. This one personally is about so I call a plant crops function, and then I need to make sure that that plant crops function is valid in the point that it's going to make sure that we have enough acres to actually plant, or we have enough wheat to actually put into the acres to plant. So if those two pass, then it carries on and goes into putting that into place inside of the game control plant crops function that it calls. So a lot like Fred's too, the switch statements are great because they are looking for specific inputs, and if those inputs aren't put in, it will tell you to, hey, you need to try again because it's not working. So, and this makes it easy for you to call your functions that you need, like in this case, if they put P, it's going to call that plant function, plant crops function, which then runs that function and is able to assure that they have the right amount of acres or wheat to actually plant that. So, yeah.
All right, and here's mine, the if and switch statements. Usually, as Fred and Taylor mentioned, the if and switch statements, they're executes the block of code that we specify, and if the condition is false, then the next block of code will be executed, and this is part of the conditional statements from JavaScript. In my case, my if statements, I just wanted to make sure that the year it's less or equal to 0, and I'm returning -1 because we just wanted to reach to the point of getting the error and making sure that's a valid number that we have. And once we get the desired results, we apply the formula to find out the number of dead that we're going to have, and display it to the user. In the other hand, the while loop, it's you help us to execute the block in different times. We can have an expression. We can have different expressions and select which one will be true. compared to the if statements, the if statements can be applied to many to a large number. For example, with a year, we can, it could be 100 years, 200 years, or just one or two. But with the switch statements, we can have something more specific, and this is how this is why we use these two statements.
All right, and here's this is my unit test. Specifically talking about finding how many vermin to generate to eat parts of the wheat based on your tithing. The very beginning of it is obviously just turning the tithing into a percent so I can use that. And my test cases focus on weaknesses within that algorithm. Any minuses passed in can really mess with how it's going to spawn things, even just one minus. The specific case that I focused on was case 5, where if I had wheat of 0, which is a possibility in the game to have no wheat, that will completely break because you can't divide by 0. And test case 6 was also one where I could, in fact, make myself have less than 0 wheat because I would generate more vermin that would eat more wheat than I currently had. Those are the two test cases that I really tried to focus on here. Aside from that, it was mostly just making sure nothing was negative, but I just had to validate that when I was getting wheat in, it had to be greater than 0, it had to be at least 1. And when my wheat was going out, it had to be a positive so I wasn't destroying the integrity of my own model.
Perfect. And so showing my test case is very similar. The great thing about these test cases is it really helps you understand or simplify what you need to do in the actual code. And so, like Fred talked about, putting in these inputs allows us to really dive into the test code and make sure that there's nothing going to break, or that our what is it called, function or formula will actually work with this test matrix that we have. So what I was looking for was making sure that we're staying positive inside of these rollovers, and if it wasn't, obviously the game's gonna have to end to a point because you don't have enough acres or population or wheat, and that's what that I really dug into on these the test cases, just make sure that the formula was correct for this and that we could carry on and move towards to the next year.
All right, and the same case for me for this the matrix test. It really helped me to identify what I was looking for, and it makes me think the different or the many scenarios that we have for invalid or valid information or data that we enter. So I have as you can see over here, we have different scenarios, the valid ones, the invalid ones, and the most important for me was to see when you mix the different information, when you enter different information, what the results will be and what I need to do. So in this case, I was also looking for numbers that were equal to greater than 0, and see what the system will do after you enter or input that information. So and this is what the matrix helped me to identify a lot better. I don't think that I couldn't done it in the same way without this matrix.
All right, here we're going to talk about scope and lifespan of a variable. So scope and lifespan are very much tied together. A lifespan is where it's going to end, how it's going to end, and the scope is the current area of the code that it's within. So in this code, we see both the scope and the lifespan take place with the player element that we've passed up here. And we're going to set that to the game, which is a part of the highest level, which means that its lifespan is as long as the program is now. So, and then with scope here, we see the cost here that's generated, and then the set acres that it's used. Now, while we do keep that in a form, that cost, the location of that is outside of its scope, and its lifespan ends when we hit return.
Perfect. And so we use the same code that Fred was talking about to display the team showcase for the pass by reference and pass by value, because it's such a great code. You know, it's so awesome that it also has pass by reference and by value. And we're brilliant enough to put it in the same block so that we don't have to show any other code. But to kind of explain what pass by reference is, if you see here where it talks about the player, that is us passing the player into that statement, and it's used it by reference, obviously. Key word there, but also the pass by value is used in the cost. So I'm putting a value inside of that cost, and then a lot like what Fred was talking about is the lifespans of both of those. We'll end at the end of this this block of code. So yeah, that's the end of our presentation. We're so grateful for the opportunity to grow and learn and keep developing our skills in Java and understanding the terminology in all of it.
All right, thank you.
As a final note, we're just going to show our test files as per the requirement on the rubric. This is Fred's, mine, running. As you can see, it passes and sends the error codes that are needed here. And the valids, valid, and the invalids are invalid. Next is Taylor's.
Yep, so we'll just go to the rollover control test, and it runs, and all valid 100%, and the ones that are not supposed to be valid are not valid. So it's perfect.
And that's the find edge for me. With the, I'm glad that he passed the test this time, and I got the same results. The ones that are invalids are there, showing correctly, and the valids, I think I don't see them right there, 173, and it's working great.
Perfect. So hey, that's our presentation, and we're so grateful. Yeah, thank you so much.
Thank
Bye-bye.
you, guys. Bye.